a full course offer in Thai UMT. I'm not sure is it an elective for you guys? No. Do you have this as your elective, machine learning? No. Okay. Maybe it's only offer for RDS and RST student. It's not offered to you. In fact, I can actually cover 14 weeks just for machine learning, supervised, unsupervised, and deep learning. But unfortunately, I have only 2 weeks to cover. So 2 weeks, 1 week for supervised and 1 week for unsupervised, and another week for neural networks. So I will try my best to squeeze everything in the 2 hours. I'm not going to cover so details, but I will just cover the very fundamentals to give you a basic idea on how supervised machine learning works, the flow of the supervised machine learning, and what are the elements is important in the supervised machine learning, and what is the challenges that we could face while you are training your machine learning, and what are the common supervised machine learning, and then the last one is how do you measure the performance. Okay, so are you ready? Okay, so this chapter is going to be a very long topic, a bit deep, and involve a lot of maths modeling equations. If you are very good in maths, probably you can easily catch up, understand what I'm trying to deliver. If you are weak in maths, it's okay. You try your best to absorb. If you are weak in maths, it's okay. You try your best to absorb. If you still cannot, it's okay. You just need to learn how to apply into the practical. That's good enough. All right. The reason I cover this topic is like in future maybe you would like to study your master PhD, then you have to study the principle, the theory behind each of these algorithms so that you can improve the performance. If you just want to apply into your assignment, yes, you just apply call the functions from the Pythons. Yeah. Okay. So before we start, have you heard about the terms of like AI, machine learning, deep learning, supervised machine learning, unsupervised machine learning? Have you heard about all these terms? Do you know what is the differences between these of the terms and what is the relationship? Is that confusing? Yeah, you have AI, sometimes you have AI, sometimes you have machine learning, sometimes you heard about deep learning, then you have supervised, it's all confusing. So let's understand first, some of the important terminologies of all these AI, machine learning, the relationship. Artificial intelligence is a very big branch, right? It's a big branch. New students, did you pay fees? No. No pay fees, then cannot attend the class.
如果他选这样，对，我们身体有没有？他一定选。
又不是那个猫叫的，我在听那个，又不是那个猫在叫的。
Anyone can help me to put the cat outside the room?
Put the cat.
Wait, so fierce.
What extract? Extract your name.
Thank you very much. Maybe he want to attend my class also. Okay. Huh?
Oh shit. 电脑太重了。
Yeah, you can want to learn. But you didn't pay the fees, so I cannot allow. Or Doraemon. Okay, so come back to here. So what is artificial intelligence is a very big branch that shows any application. It is actually applications that having human behavior. So in the past, we have seen some of the applications of AI like the Waze, and then we have a chatbot. As long as it's able to behave like a human, chatbot perform like chat like a human. Then we have like the last week we learned about the Google search engines, right? Search engines, all these are applications. It's all part under artificial intelligence. No matter what kind of methods that we use, we can use predefined rules, we can use machine learning, we use deep learning, we don't care. As long as that application consists of human behavior, then we will so-called artificial intelligence. Then scoop down, we have this branch called machine learning. So what is machine learning here is actually a technique. Yeah? Artificial intelligence is applications, but machine learning is technique. It's a technique that used to achieve the artificial intelligence, right? So we are going to use this machine learning to achieve or to build the AI applications. So how machine learning works is actually based on like learn the past experience. Yeah? Learn the past experience, discover the patterns among this data, and then to make its own decisions. So when we say make own decisions, we have several ways. The first way is using the rule based. If you see A, then I decide it is B. If I see B, this is C. So this is predefined rules. But meanwhile, machine learning, we no longer put the rule based. We're not going to put if, then else. We just throw all the data to the machine learning, let the machine to discover the patterns of the data and to decide the result by itself. I believe you have gone through the practicals already, yeah, for the NLP, for machine learning. You have seen you never use if else statement. Yeah, you just throw the data. Yeah, you clean the data, you throw the data into the machine or the model, and the model to decide. Then meanwhile, we have even specific branch here is called neural networks. So neural network is a subset to the machine learning. It is also used to predict some things without explicitly pre-programmed, or without means that we didn't provide the rules. But what is the difference between machine learning and neural network here? Machine learning, as I mentioned, we need features, so-called we need data sets, right? We get from the Pythons, we get from the NLTK, we get from the Kaggle, whatever. We obtain the data set before we train the models, right? Before we used to train the models, we have to go through one process. It's called features extractions. Okay, we need to identify in this data set which features is very important, or if this is important, we extract. We extract, then we throw into the machine to learn. So we have to do this manually. Okay, we have to do this manually. Okay, so you need to equip some of the knowledge like which how to perform some features engineering, which features are important, then you extract and you train the models. But by using the neural networks, same, you need a bunch of data sets. But before you train the models, you don't really need to extract the features. Okay, but you just need to clean the data and you throw the data into the neural networks. And the neural network itself, during the training, you will adjust a parameter called weight. Okay, you will adjust the weight, okay, until you find out which features is very important or very significant, which features are not significant, are not very important. Then we will actually not going to use that features to train the models. Okay, that's the difference between machine learning and neural networks. I'm going to cover what is neural networks 2 weeks later, right? So now you just need to know the difference between machine learning. We need to manually select which features is important. But neural network, meanwhile, in other hands, right? So we just throw the data, and during the training process, these models will actually use a technique called back propagations, right? We train the models and then come back to here, keep adjusting the weight. So this weight here is used to decide whether the features that you use is significant or not. If not significant, the weight eventually will give a very low value. The features is very significant, that eventually the weight will be very high value. Okay, so it will keep adjusting by itself, okay, and then eventually identify all these features important, okay, then use it for training purpose. Okay, but however, neural networks here is more expensive, I would say. Normally we need GPU, right? And then machine learning, we just need to use a normal CPU is good enough. Okay, so normally we use ANA for more complicated so-called applications. For example, the object detection, image that deal with the images. So for deal with images, then you use CNN, convolutional neural networks. Then we have a recurrent neural networks. So for time series, for example, NLP, you want to predict the stock market, then you have to use neural networks. So which is more complicated applications, then you use neural networks. Okay, so don't worry, I'm going to cover how to so-called adjust. You'll see the whole process, how the neural network actually adjusts the weight during the training process. We have a simple mathematical calculations 2 weeks later on. Then what is deep learning? So deep learning here is referred to the depth layer in the neural network. Means that we are going to use these neural networks, okay, to duplicate more neural network to form deep learning. Okay, so in other words, deep learning is actually built using neural networks. Okay, meanwhile, neural network is a subset to the machine learning where we will let the machine to decide which features is important. Machine learning, meanwhile, is going to extract your own features. Right? You have to extract your own features. It's a technique, and then it is a subset to build the artificial intelligence applications. So that is the overall picture, the relationship. Okay, so you may wonder, then how about supervised machine learning, unsupervised machine learning, semi-supervised reinforcements? Okay, so go to the other one. So machine learning itself has many so-called variations. We have a supervised, we have an unsupervised. Okay, we have the so-called semi-supervised. We have a reinforcement supervised. So it's just a type of machine learning. I'm not going to cover everything for our syllabus. I will just cover this supervised and unsupervised, which is the most common technique in machine learning. So for the semi-supervised and reinforcement learnings, then you have to study yourself. But now we have others machine learning like the self-learning, and then we have a transfer learning. All this you have to study yourself. So I'll just cover the what is supervised, so what is unsupervised, what is the purpose, the process flow, and the techniques. Okay, so now are you clear with the pictures? And what is machine learning? What is AI? What is deep learning? So what is neural networks? What is unsupervised? What is supervised? Okay. Agak-agak lah. Okay, you look at this picture, then you know that it's actually a subset. Okay. So yeah, this is what we're going to cover today's supervised learning. Hopefully by this 1.5 hours, I managed to cover everything because there are too many things to cover. Okay, so that is the definitions given by Kavins. It says that machine learning is a method that automatically identify the pattern in the data and then use this kind of uncovered patterns to predict the future data. Okay, and making under uncertainty. Okay, Alright, so that is the definition. You don't really need to memorize these definitions. I'm going to show you a few examples, then you will know what's meant by patterns, what's meant by models, what's meant by predict. Okay, so to have a better understanding on how machine learns, you should have to understand how human learn first, right? If you understand how human learn, this is exactly how machine learns. We just copy the same ideas into the machines. So machine learn through the mistake, the trial and error, and observations, right? Like today's, let's say raining, then you go and run under the rain, then you fall down. Sorry, I look at your head there. I feel very funny. Very cute. Okay. Now where do we stop? Okay, it's raining, then we run under the rain, then you fall down. Right? You feel very pain. So if tomorrow rain again, are you going to run? Yes. So how should I continue? I expect the answer is no. Most of you won't run, right? Because you know that if you run, you fall down, you feel pain, right? Yes. So this is exactly how human learn, right? You learn from the experience, observations, mistakes, right? And then in futures, you will see the same condition again. Then you know, okay, in the past, I do this, so I make mistakes, so I'm not going to repeat my mistake again. So same with the machine. So machine is going to learn this experience. Okay, learn the experience. So in future, if you see these pictures, this condition, okay, then he can make decision. What he want to do, without pre-program, without preset. Like okay, if you see rain, what you're going to do? No, we are not going to put this condition into the machine anymore, because the machine is already learned how. If let's say they have these conditions, it's not going to repeat the same mistake. Okay, so give you one example here. Assuming that we have a two group of students here. Okay. You look like this. Yeah. You have a few students here. Yeah, spelling, and then they score very high CHP7. So I put them in the excellent grades. Let's say you look like this. Okay, and then you have another group of students. Yeah, look,
这
very
个
weird.
图在下面。
This one look like you.
考试的时候不带
This
字
one. This one. This one. Look like you. Exactly the same. Okay. Okay. So we have a few students here.
香也是。
Yeah.
香。
Right.
可以找他。
Yeah. Look like the same.
你那个也是很像。
Reverse the grade, no. Average grade.
紫色的老头。
Yeah. You have a two group of assumption. So you have two group of students here. Yeah. First group of students look like this, and second group of students look like this. You have different appearance. You have excellent grade and you have average grades. Oh, 3.9. Okay, later I change, later. Oh, 3.9. Okay, so, alright. Okay, so now, assuming that you have a new student that transfer from Penang branch. Okay, look like this. Wearing a spec. Okay. Anyone look like this guy? No, all normal. Alright. So now I would like to predict whether this guy belong to excellent grade or average grade. Because I want to predict so that I can adjust my syllabus, adjust my let's say the practical, adjust my test according to the student level. Right? Can you help me to predict whether this guy, okay, eventually will score excellent grade or average grade? Average grade. Why you say so average?
Because I'm racist. Because I'm racist a bit.
Oh, okay, very good. EJ say, why? Because most of the students that score average grade, they have the same features, where they're wearing the spec and they have this beard, right? Same. But meanwhile, you will look at the excellent here, none of them wearing spec, none of them having beard. So
靠眼睛也是掩盖不了你的 average face.
yeah, okay. So the machine will predict. Okay, not machine, you. I'm asking you. Right. So you predict that this guy eventually belong to average grade. Why? Because all of this beard, spec, all this, right? That's why we are actually analyzing, right? Analyzing the this hair length, hairstyle, or that's not what your friend says. Because that guy's having a so-called spec, and then you have a beard here. That's why it belong to average grade. So all this hair length, hairstyle here, we call it as features. Okay, we call it as features, and then the excellent grades, average grade here, we will call it as labels. So these are the two very important elements in supervised machine learning. We just need these two informations, right? We are going to collect these features and then as well as corresponding labels and train the machine. As I mentioned earlier, we have a data set is not enough. We have to manually extract the features. But in this case, we have to extract what are the features among these students. We cannot just throw this image into the machine. We have to extract the features and tell the machine, okay, help me to extract the features and then train the model. If you are using neural networks, if you are using this method, you can just throw the image without telling them what are the features. The machine will eventually find their own features. Okay? So this is features, this is the label, so that you try to match there how many correct, so-called how many match features towards this new face here. So you will see that if excellent grade, there are only 2 features, but for the average grade, there's 1, 2, 3, 4, 5, 6. High so-called frequency. That the probability is higher. So then you can predict that this guy is actually belong to average grade. So this is how humans do the predictions, right? So we have the past experience, then we learn, then we based on these features, we make a predictions. Right? It's very as simple as that. So same goes to the machine. Machine doesn't know anything about the food, anything about the face. So we have to tell them. We have to tell them that, oh, hey, let's say in this case, you have a red color, the size is big, this is apple. Then the machine will learn, okay, you have this features, okay, so this is apple. So you have an orange color, this is big or this is orange. Okay, so the machine will learn these features as corresponding this so-called the labels, and then they will learn. So in future, if let's say you give a object red color, the size is medium, then maybe the so-called the machine learning will predict that it is apple based on the past experience. All right. Okay, so are you clear now how machine learning works? Based on the features, based on the labels, learn and then to predict. Okay, so in general, classifications, prediction is like human learn from the past experience. Computer doesn't have the experience, so it learns from the data set. So which represent the past experience, right? So machine doesn't have experience, right? We as a human we have, right? So we go through so many years, we collect the experience, but machine doesn't have. So we have to provide them the experience using the data set. So we have to collect the data set from the internet, whatever, and then pump into the machine, let them to learn. Okay, so in the supervised machine learning, we need two elements, as I mentioned. We need X here is the input, and Y is the output. So X here input, I call it as a features. Y is the output, I call it as a label. So we need these two information into the machines. Okay, so that's the overall process flow for supervised machine learning. So perhaps you had already seen these pictures in your practicals, where we have the data set here in any format, yeah, in the text, image, sound. So we have to extract the features manually. Extract the features manually together with the labels, and we put inside the machine learning models to learn. Okay, so learn, but then we miss out one process here. After you train the models, you have to assess. Yeah, you have to assess the performance first. If the performance is good, like accuracy is like 80%, 85%, then we will use for predictions. So during the predictions, we have a new samples. We need to extract the same features. With the technique that you use to extract the features here, you have to apply the same technique to extract this feature as well and use for predictions. Okay? Alright, so this is where to get the data set. There are many places, right? So first one is the public data set. You can get it from the Kager, the most famous one, or UCI, or from the Python itself, the library. There are a lot of like the NLTK itself. You can extract the name list, yeah, from the NLTK. If let's say you want to do some research, but the data set is not inside or is not so-called cannot obtain from the internet, so you can actually buy from this kind of website, awsdata.words, or you can actually scrap your own data set from the so-called Instagram, Twitter, Facebook, and so on and so forth. Okay, but there are limitations to let's say web scrapings and obtained from the company data set. It's where you have to perform a lot of pre-processing. Yeah, the data that you obtain from the internet, like the Kagers, they are already in the perfect form. They are already cleaned by somebody. Then you just apply and train the models. But if you are obtained from the company, then you have to do a lot of work. Especially, they will just throw you the raw data. So in the raw data, there are a lot of missing data, outliers, noise. Then you have to clean them before you train the models. Okay. And the web scraping is depends on some website you are not allowed to scrap. Yeah, some website you are allowed to scrap. Okay, so after you scrap the data, you obtain the data, you have to your phone. Okay, I thought somebody is screaming. Alright, so we have this pre-processing step. I'm not going to go through everything here. It's just to tell you that once you obtain the data set, you have to check your data set very clear. Yeah, is it clean enough? Or if not clean enough, then you have to process some, let's say that handle the missing values. You have a lot of files, right? How do you integrate them? And then you have so-called the data that the range is very big. Then you have to perform some normalization and so on and so forth. So if I want to go through this, then I will take a few hours. So just let you know that we have to perform a series of pre-processing, right? So after that, then you have to ask yourself, after you have this data set, what you would like to do. So you want to predict continuous value, like the revenue, okay? Or you want to predict like the stock market value. If let's say you want to predict the stock market, the revenue, the sales, then you got to use these methods, linear regressions, gradient boosting, error boosting, decision tree regression. If you want to classify your data into like different categories, like humans, not humans, yes, no, spam or not spam, true or false, then you have to use classification methods like logistic regression, decision tree, random forest, and so on and so forth. Okay. So I think application of using machine learning is very common nowadays. We have seen in the practicals, identify the spam or not spam email. object classifications, yeah, face detection recognition is all using machine learning. So let's move on to the first algorithm. It's called linear regressions. Yeah, for my students under my projector, I have already explained to you what is linear regression. But in case you still cannot remember, you cannot understand this, I will explain one more time. So linear regression is a typical algorithm that used to predict the continuous value. Okay, in fact, you had already learned this while you are in the secondary school. Okay, so in your secondary school, you have a x and y data. Your teacher will ask you to plot onto this 2D graph. So you have the x here. Let's say this is your age. This is your income, right? So you plot the graph. Okay, you plot. Okay, after you plot the graph, you can actually build a best fit line. Have you heard about this term, best fit line, right? So what is best fit line? Best fit line is a line that tries to join all these data together by minimizing the errors, right? So assuming that you have this data 1, 2, 3, 4, 5, 6, 7. So we want to draw a best fit line so that we want to draw a line that try to join all these data points together. So you can draw here, you can draw here, you can draw here, but the best one maybe I will assume that you can actually draw this line by minimizing the errors. What is mean by errors? This is the errors. So this is your predicted line here. Then this is the actual point. The discrepancy between the actual point and the line is your error. So the model will try to find which line here having the minimal error. So this is the error. Okay. So what we like to do with this best fit line? So after you build the best fit line here, we will obtain an equation, which is A equal to ms plus c. So in this equation, we have two constants here, which is m and c. So what is m? Gradient, right? M is the gradient. C is the intersection point, right? C is the intersection point. M is the gradient. This is the m. So where you can obtain using the theorem Pythagoras. So because we have x1, we have x2, we have y1, we have y2. So you can just use this x1 minus x2 square plus y1 minus y2 square. You will obtain the m value. So after you build these models, you obtain the m, you obtain the c, you will just substitute into this constant value, then you obtain some equations. Like for example, in this case, 0.23x plus 13.82. So this is so-called the machine learning model. This is your machine learning model. Okay, so when we are talking about machine learning, it's actually looking for the optimal value of this constant and build this equation for you. This is so-called machine learning models. So what we can actually apply in this machine learning? So we can predict, assume that now I want to predict when x is equal to 10. I will just substitute this 10 into this x. So it's become 0.23 times 10 plus 13.82. Then I will get what? 2.3 plus 13.82. Right? So it's equal to what? 16.12. That's it. So this is my predicted y. So it means that we have this scatter plot, which is the past experience. This is your past experience, your data set. So we would like to build this line. This line is your machine learning model. After you build this line, you will obtain these equations. So this machine learning will find the optimal value of these two constants. Then you obtain this equation. So we can use this equation to predict the future, to predict the y, given the x or the features. That's it. Okay. Yeah, you have learned this in your secondary school. Huh? So just a revisions. Okay. Section. Boleh? Until this test, okay. Okay. So sometimes you can have this different type of graph here. You have to depend, right? If let's say you have this kind of graph, then you cannot use linear regressions. You have to use polynomial functions. Maybe x power of 2 plus x plus c. You have to use different functions. In this case, I assume that data are linearly correlated. Then I can use linear regressions. If your data or your scatter plot is not in linear regressions, then you have to use other types of regressions, polynomial or non-linear regressions. Okay, so now let's move on to the most very important subtopic here, called overfitting. So what is overfitting here? Overfitting is a phenomenon where you overtrain the model. Right now, train means I'm trying to build this model. When I say train, it actually means I'm trying to find the optimal value of M and C. Overfitting means that I overtrain the model in such a way the model managed to just memorize the pattern between X and Y. Just memorize the pattern X and Y until this machine forget how to predict the new features. It cannot predict already because it just so-called memorize the pattern between X and Y. So that's theory ways. But how do we measure the overfitting? You have three different situations. You have a overfit. Overfit is where your training accuracy is very good, but your testing accuracy is very low. You have another situation is when fit. Fit means good. So how do we measure the fit? Is where your training accuracy is good, your testing accuracy as good as well. You have another third phenomenon is called underfit. Underfit is where your training accuracy is very low, your testing accuracy is very low. There are a lot of factors that cause overfit, underfit. It could be caused by your data set. It consists of too many noises. It could be due to you have some outliers that you didn't clean. It could be due to your models, your machine learning models. You use the wrong setting. You use the wrong machine learning models. There are too many factors. If you have these situations here, then you have to check it, troubleshoot one by one, starting from the data set. Okay, and then you check your algorithms. Okay, now I'm going to explain to you using these regressions. Yeah, how do we visualize, get a better understanding of what is overfitting. So overfitting happens in every single algorithms. It's not only linear regression. It happens in decision tree. It can happen in logistic regression and others algorithms. Okay, I'll give you this picture here. I'm going to use 5 data points. Let's say this. I have a 1, 2, 3, 4, 5. I have 1, 2, 3, 4, 5. Okay, and then I'm going to draw another 5 point. 1, 2, 3, 4, 5. Okay, so in this case, I'm going to use x power of 2. Polynomial function x power of 2. So I'm going to use x power of 2, then probably this is what I obtain. Okay, this is what I obtain. So as I mentioned, this line here is your predicted model, your machine learning model your machine learning model. I put a dotted line so that I mean this dotted line representing the projection, right? Then this one is dotted line here. Okay. So this is your machine learning model. So you have some equations here. So how to measure the errors? So it's actually a discrepancy between the actual point and also the machine learning model. So this is actually an error. Okay. So this is the actual point. So I'm going to use this actual point to build this model. That's why this is equal to error. So this error is referred to training, during the training. This is the error during the training. So you can see there is some error here, right? There's some error here. But it's still acceptable because it's very small. Okay, still acceptable. But you try to look at this higher polynomial function. Let's say I use x power of 4. Okay, so maybe this is what I obtain. Follow that line. Okay, so let's say I obtain this model. So this is my machine learning model using x power of 4. So what is the error? The error is very minimal. The error during the training is very minimal. Means that the discrepancy between the actual point and also the machine learning model is very small because I'm using high polynomial function. The error is very small. So it means that if you're using training x power of 4, your training accuracy is very high, right? Near to 0. It's all perfect. But this one, your training accuracy, okay lah, but lesser than x power of 4. Okay, right? Because there's some error, but it's still acceptable, right? Assuming that the training accuracy is 80% in this case, so this one is there 99%. It's very close. Okay, now let's create a new sample point, a point that never seen by the model. If I try to put this a new sample here, what are new samples? So same, I create a new sample here. Now I try to ask the machine learning models to predict the new sample, to predict the y of the new sample. So this will be the error. This will be the error during testing. This is something new, unseen sample. I will call this as testing sample. Okay, when you use a testing sample, you have some error also, but the error is very small. Okay, so I will get the testing accuracy. Okay, quite okay, maybe 80%. Okay, but if you look at this, I have these machine learning models, I have this actual sample, but the discrepancy here is very big. It's very big here, right? So then this one, the test accuracy dropped a lot, maybe back to 60%. So it means that although you use a high polynomial function, you will obtain a very high training accuracy. But when I give a new sample to this model, it fails to predict the y value. But if I use an x power of 2 here, although there is some errors here, but still acceptable. But using this x power of 2, it managed to predict the y value for this new input. This is so-called, I have high training accuracy, I have also a high testing accuracy, acceptable. But in this case, very high training accuracy, but suddenly the testing accuracy dropped a lot. Okay, you can think in such a way that you're studying the book, right? Your AI books. Right? If you just memorize without understanding, right? You just memorize everything. Okay, now you sit for the exam. So during the exams, I have 80% of questions that come up from the books. You can answer very good because it's all from the book. But there is remaining 20 questions. I twist the questions, I change the questions. It's still within syllabus, but I change the format, I change everything, and you cannot answer already. It's something new. It's same in this situation. If you just memorize everything, now I just memorize X, I have this X, I have this Y. I memorize all the contents from the book. Then I can answer the question right from the book 99%. But I give a new question, twist the question, and you cannot answer already. It's something new. Okay? So you just remember this overfit is what? During the training process, the error is very small or the accuracy is very high. But when I give a new sample, it fails to predict the y value. Or in other words, it gives a very high error values. This is called overfitting. This is common. This is very common in the machine learning. So when you have this situation, as I mentioned earlier, you have a lot of factors. You have to check your data set, you have to check your models, you have to check your parameters and everything. Okay? Right, so this is just the beginning. We still have another 4 more complicated one. I try my best to use very simple terms to make sure that you can absorb. Alright, so that is for linear regression. That's for continuous value. Right? You want to predict the sales, the revenue, and you use the linear regression. So if you want to predict the class, right, if this is good, this is bad, this is a spam or not spam, then you have to use classification methods. So I'm not going to cover others, like you still have like random forest, you have an XGBoost, but I'm not going to cover that. So I will just cover the most fundamental ones, which is the k nearest neighbor, decision tree, support vector machine, and bias classifications. Okay, let's move on to the k nearest neighbors. I'm not going to cover these theories, so let's move on to these examples. So learn from the examples here. Okay, assume that we have a guy, Christopher, and I use you as an example. Okay, good. Handsome. Okay, so assume that this Christopher is a very handsome guy, huh? Playboy, yeah, playboy. Okay, so he is a playboy. Huh? And to assumptions. One also I will. Single, anyone? Please recommend. Yeah. Assuming that Christopher is a playboy, you know, and then he's very cut out. Whenever there's a new girl come to the class, then he will like, oh, cut out, then he want to tackle it. Okay, yeah, tackle also. So based on the experience, history, he tackled 11 girls before. 11. Playboys, playboy is still a playboy, right? 11, 11 too much. Okay, so out of that 11, there are 7 girls rejected. 7 rejected Christopher. Okay, but however, there are still 4 accepted Christopher. But X already lah, broke up already. Because this is past experience. This is the data set. So out of 11, 7 accepted, 7 rejected, 4 accepted. Yeah, huh? But rejected already. I mean, X already. So we have 7 rejected. So I will label it as a green color here. 4 red color accepted. Okay. So now there is a new girl transfer from Sabah branch. It's known as Cinderella. You have a new girl from Sabah, Cinderella. Yeah, come to the class. Again, Christopher look at the Cinderella, wow. Then cut out again. So what will do? So the Christopher want to take action. But before he take actions, he want to predict first. So I invest into the Cinderella, because to tackle girls you need to spend a lot of money, right? So the Christopher want to predict first whether the Cinderella will accept or reject. If reject, then I don't want to tackle, I don't want to take action. So what he can do here is we will collect some features or from the past experience. Okay, for example, the height of the girls, right? That rejected Christopher before, as well as their length of the head. Okay, we collect these two informations. So we collect. So we have some value, numerical value here. For example, height is 170 cm. The length of the head is 150. Then we plot here. Then we plot. As well as the girls that accepted Christopher, we also collect the informations in numerical values, the height and the length of the head. So we will collect. So we will plot in this case. But if you have a 2D, you have a 2 features, then you will have a 2D plot here lah. But if you have a 3 features, more features, then you will have a high dimensional space. Okay, now we would like to predict whether eventually this Cinderella will belong to this class or belong to this class, which is reject or accept. So what we do here is, first we have to measure the distance between this unseen data, which is Cinderella, with all the data sets. Okay, so in other words, we'll have this case. Let's say this is Cinderella. So we have some point here, and then we have, let's say this is accepted. I put as the start. So we have to measure the distance. So this is D1, D2, so this is D3, D4, and so on and so forth. We have to measure the distance between this data set to the Cinderella. Okay, so after you measure it, the second step here, you have to predefine the K value. This is the first step. You measure the distance. The second step, you have to define the K value. There's no standard way to get a K value. You probably have to perform trial and errors. Like we perform several numbers of K and then check the result and then get the optimal. That's the only way. Yeah, so that's the limitation of K nearest neighbor. You have to manually select the number of K. So let's say K, the optimum K value that you select here is 3. So what does it mean by this 3? So this 3 here is referred to the 3 closest point to the x value. 3 closest point to the x value. In this case, let's say, assuming that you had to measure the distance. So the 3 closest point will be D1, D2, and D3. Correct or not? So how to measure the distance? Same, use the theorem Pythagoras. Use the theorem Pythagoras, x1 minus x2 square plus y1 minus y2 square. So that's the only way. So you measure the distance. And then if I set 3 here, then I will obtain the point that's closer to the x. Only 3 points. So assuming that these are the 3 points that's closest to the Cinderella. Okay, so now done. This is step 2. Now in the step 3, forget about this. Forget about the point that's outside the circles. So now ask yourself, within these circles, there are how many points belong to yes and how many points belong to no? 2 belong to no. There's only 1 point belong to yes. Therefore, we can make a conclusion. This Cinderella eventually will reject Christopher. That is how. Yeah, not asleep. Moving on. Okay, so this is how K nearest neighbor works. It is very simple. It's just based on the distance. We just measure the distance. Okay, measure the distance and then define the K values. And within that K values, then we have to calculate the frequency. The X will belong to the class that having the highest frequency. Like in this case, right? So X, the no here, you have a 2, but there's only 1. Belong to yes. Okay. So this is K nearest neighbor. So we, in this K nearest neighbor, we do not need to train. There's no training process. We straight away apply the data set, find the distance. Therefore, the testing time will be longer because during the prediction time, you have to measure the distance. Okay, find the probability. But there's no training time. There's no training process. There's no so-called training model. There's no equation. Like in this case, we will build the models here, equation. But next case, there's no equation. We just find the distance. Okay? Still okay? Can nearest neighbor? Alright. So let's move on to a typical one. A little bit difficult one called decision tree. So decision tree is a very famous technique that has been used in a lot of companies. But they're not going to use decision tree. They use the improved version of decision tree, for example, the attribute, the random folders. So decision tree is the fundamental, is the so-called the original idea. So if you can understand this, then you can actually understand the random folders or other variations here. Okay, so there are 2 questions that you probably can ask using a decision tree. The first one is how to build the decision tree. So after we build a decision tree, so this is a tree, right? Tree is a tree-like structure. After we build a tree, so how can we use the tree to predict new samples? So assuming that we have a case where we have 3 features. Is it you are the homeowner? What is your marital status? Are you married or not? And what is your annual income? So we want to use these 3 features to predict your credit rating. Are you a good credit rating? Are you a bad credit rating? So we have 3 features to predict the Y. Okay, so if you use a decision tree, you use these algorithms. Okay, you use this algorithm, the practicals. You use just 2 lines of code, then it will build this tree for you. Okay, it will just build this tree for you. So in this tree, the first node here is actually referred to root node. Okay, it's one of the features. And then in the second level, in the third level, you will see there's a green color here. This is called internal node. It's also referred to the features. This is the first feature, the second feature, the third feature, right? And then the leaf node here is referred to the decision, which is the Y label. Okay, it's a label in the yellow, is the Y. So you have a decision, and then you have features here. So how are we going to use this tree to predict something? So assuming that again, Christopher, we want to predict Christopher having a credit rating good or bad, right? So good or bad. So we will find out find out the Christopher features first. For example, Christopher, is it a homeowner? What is his marital status? What is his annual income? So we collect this information. 50,000, 80,000 here. So how do we predict? We will go through these three first. We ask the first question: is Christopher a homeowner? We will check no. If it is a not homeowner, we go to this direction. Okay, ask second question. If Christopher already married, so we go to this direction. So this is the predictions. The machine will predict, given these situations, Christopher have a good credit rating using a tree. Okay, this is how this one. Less than 80k, then you are good lah. If more than 80k, then you are considered bad. In bad credit rating or good credit rating. This is not sure. This is how a machine learning build. So we cannot control. It's based on the past experience and they build the tree for you. We cannot control. Yeah. Okay, so this is how machine learning. This is how decision, this so-called decision tree predict the output. Okay, so now look at the second example. We have this again 4 features. We use the 4 features to predict the y value here. So again, if by using the decision tree, it will build a tree base for you. And then how to make decisions or predictions? We look at this input. Let's say age is less than 30 years old. So we ask, or age less than 30 years old. We go to this direction. Okay, is it a student? Yes, it is a student. So I predict that this student or this person will buy the computer. That's it. Using the tree base. Alright, but my question is, why we should put the age at the root node, but why not put the student at the root node? We have 4 features here. Okay, if you put credit rating, you will obtain different structure. If you put this student, you will get different structures. But why we put age first? No. Thank you for your answer, but that's not the way. Yeah. To build this decision tree, it involves a very complicated process. Okay, it depends on these equations. It's called information gain. Okay, to decide which attribute should go first, student, age, credit rating, it depends on this value called information gain. Okay, what is information gain? Is basically use the information minus the entropy. So before we move further, what is information, what is entropy? I would like to give you some situation first. Okay, I want you to think. You have this. Let's say you have a kilang. You have a factory. Your factory is building manufacture some marbles. Okay, so you have a lot of marbles here, which is a small size, large, and medium. Okay, so I want you to put a filtering system. I want you to build a filtering system in such a way. You want to filter that small size 1 category, large size 1 category, medium size 1 category. Okay, what you will do? Okay, you can put a large funnel first, a filtering system. You can put a large funnel, and then if you put a large, this one can go through, right? This also can go through. This also can go through. So eventually, you will still remain as L, M. Okay, then you can put a medium one. If you put medium one, large will start here. Medium can go, S can go. So what you will get? You will get all the marbles in the large size. Continue. So here you will remaining S and M. Okay, so you can put small. You put small, M will get stuck, S can go through. So you will obtain a group of medium marbles. And at the same time, you will get the S marbles. Correct or not? You can have any second situation here. S, large, M. Where you put medium first. If you put medium, large get stuck. M go through, S go through. So you will get the last marble at the first stage. You will get S and M here. Then you put, let's say, M, S, small. If you put small, go through these funnels, M, start, so you get M. Eventually you get S. Same. But how many process for the first one? 1, 2, 3. You go through 3 process. Try it out. But this one, you go through how many process? 2. Go to 2 process. So this is exactly how decision tree builds. Why we put H first? Why we put credit rating first? It depends on where you want to put the funnels. If you put the large, medium, small, you go through more processes. If you put this medium first and small, you will get to. You can also put small first, large first, medium. You have different variation. You have different combinations. But we want to find out which combinations give you the least number of process. You want to achieve the goals as fast as possible. So it same go to the decision tree. There is the reason why the machine learning or the decision tree put H first, not student first. Because if you put student first, probably you will get more branch here. You will get more process. If you put H first, you probably you will reach the destinations earlier, faster. Okay, so how to decide whether you want to use medium first, you want to use last first? It depends on this information gain. So this gain here is using informations. Information is referred to the information at this stage. Okay, the information that you're having this stage minus the entropy. So that is the equation. You can assume that the gain here is the measurement of how ordered is your data. How ordered. This is not ordered yet because you still have S, L, M. This is okay, quite ordered because you have only S and M. And this is ordered because you have only S. Order means complete. When you have one group but you have only one type of marbles. Complete. How complete? How complete is your data? How complete is your data? How organized is your data? Information is information at this stage. Last one, what is entropy? Entropy is a type of impurities. Okay, it's a type of impurities or noise. Okay, we would like to remove this entropy. This is the noise. You have different way to measure the noise. The first way is you use entropy. You can use also Gini. If you search so-called YouTube or whatever, you will probably see this kind of term. This is the method to find out the impurities. In this syllabus, right, we will just focus on the entropy. Right? We're not going to focus on the Gini, but I'm going to focus on the entropy. So, but how to find the information and the entropy? This is the equations. But you don't really need to know that why we put the log 2, why there is a daughter here. There's someone had already tested it, and this is the equations. Alright, so we just want to apply, right? Substitute this, get the information from here, substitute into here, obtain the information, put this value into here, obtain the value as the entropy, and minus get the information gain. That's it. This is our purpose. The machine will just get this information, put in the equations, obtain the information gain. That's it. So what is the information gain? This is the ideas. Okay? In this case, the information gain is where your data, let's say in this place, okay, your information gain, you will get a very high value. In this case, the gain will get a very low value because still massive, it's not complete. That's why you get low information gain. In this case, the data are already complete, right? It's organized in structure, so that you have obtained the high information gain. That's the idea. Okay. I know it's a little bit difficult to understand it, so yeah, you try to digest this. Yeah, that's the idea. You just always refer back to this situation. We want to obtain a situation where you have a less process, as less as possible. At the same time, you want to obtain this data as organized as possible. Okay, so how to obtain? Using this equation. That's it. That's the story. Yeah, that's the story. Now, how to build it? So let's look at this a little bit on the calculations here. Yeah, a little bit of quite difficult to understand as well. All right. So at the beginning stage here, at the first levels, you have 4 features to choose. You want to put the root nodes. So you can put age, you can put student, you can put credit rating, you can put what else? Income as the root node. But which one to choose? We would like to find which features that give you the highest information gain. Then we will put inside here. Do you remember what is information gain? It's where your data is in structured, in organized. It's why we want to find out which features, is it age, income, credit rating, or student, which features give you highest information gain, then we put at the highest node as a root node. Okay, so how to obtain it? The first thing first, remember this equation, gain equal to information minus entropy. So this information is referred to the information at this level, but you don't have nothing here. So how to obtain the information? You have to find out from the data set, there are how many of the people that will buy the PC. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 will buy the PC. 1, 2, 3, 4. 4 will 1, 2, 3, 4, 5. 5 will not buy the PC. That's why we have will buy the PC is equal to 9. Will not buy the PC is equal to 5. So we have these two values. Just substitute into these equations. Then you will get this 0.94. So this is the information at this level. That's so far you 0.94. Okay, in this stage you have an information called 0.94. You just substitute into these equations. Okay, next we would like to find out the entropy for each of these features. How randomness of this data? How noise, how impurity, how not impure is this data? So we want to find out the entropy for each of these category. So now let's focus on the age first. Then you just focus at this age. Forget about the income, student, and credit rating. Look at the age here. Under the age, there are how many categories? You have less than 30 years old, between 31 to 40, and more than 40 years old. You have 3 categories under the age. So you draw a table, age, you have 3 categories, less than 30 years old, between 30, 40, and more than 40. So among this data, less than 30 years old, let's say, how many will buy the PC and how many will not buy the PC? Look at this less than 30 years old. 1, 2, 3, 3 will not buy, so I put the 3 here. Less than 30 years old, how many will buy the PC? 1, 2, so I put the 2 here. Then I will substitute this P and N again into this equation. I will get some value here. I will repeat the same process for other categories between 30, 40, and more than 40. I get this value. So I need this information so that I can substitute all this value into the entropy equation, which is this step 2. I will substitute this value into these equations. You will obtain 0.69. This 0.69 is referred to the entropy. This is 0.69. Okay, entropy is the randomness, is the impurities. We obtain the 0.69 for the age. So eventually what we'll do, follow this equation. Informations minus entropy, you will obtain 0.25. So this is your information gain for the age. Repeat the same process for the income, credit rating, and students. You have to repeat. And if you repeat, this is what you obtain. 0.29, 151, 0.48. Okay, then you compare which one having the highest information gain. 0.25. So age will having the highest information gain. It means that if you use age, you will achieve your goal very fast. But just like in this case. This case, you will have a highest information gain, you will achieve the goals as far as possible. So since age gives you the highest information gain, then I will put age in the root nodes. Now you finish, then you have to explain age under you have 3 categories, right? less than 30 years old, 30 to 40, more than 40. Then which node to put as the internal node? Repeat the same process. This is decision tree. It is a very complicated, but fortunately, you just apply in the practical. You just call the function, and the function will build this tree for you. But how decision tree is being built, it depends on this equation. That's it. Okay, so we take a break for 5 minutes. Yeah, we come back for more complicated one.
Oh, the yes
Don't
no
worry,
buy
not
from cert.
going to come out from exam. As I mentioned, if you cannot catch the ideas, I understood because it's very detailed, I mean quite complicated. This is considered the most complicated one. But don't worry, you just need to learn like how to apply, right? How to get from the scikit-learn. That is good enough. That's good enough. In case you don't know where to obtain the code, right? You don't know what is the code, let's say random forest. So you have to go to the website. It's called scikit-learn. Yeah, you go to the scikit-learn. You go to this website. Okay, because we are doing prediction classifications, you go to the classifications. Okay, so in the left-hand side here, there are the list of supervised machine learning. Yeah, assuming that you want to obtain the so-called the keywords. Okay, decision tree. Yeah, here decision tree. You click inside the decision tree. It will show you the. This is a regression. I'm going to go to the classifications. So it will tell you the explanations. This is all the explanation here, as well as it will provide you the algorithm name, decision tree classifier. Okay. If you don't know the theory, it's okay, but you must know the so-called the name, the function name. So you just call and then apply. Then the machine will do the task for you.
又开始狗叫了。这种东西哦，因为它刚出，看到用的人多了，你就顺眼，是这样。之前也是有人讲那个 iPhone 那个变4个 camera 很丑，然后是不是用了很爽？ 然后之后那 camera 啊，跟 T shape 我都不奇怪，我已经会这样。哇，你已经半成品了，再加一个 iPhone，无敌啊！
是有点。哦，我那一天都要去登住的不可能去。一个原始的。这是这个来数学是有问题。是。我要尝那个吃。是学学。你发疯了？你还好吗？
读 IT 的一个样子。
又开始开一
哲涛有带书吗？哲涛有带书吗？啊？书。
小黄书，
小红书啊，在我电话里面。等下你要秀给他看的。秀给他看你的那个在电话里面看的什么？
有带电话吗？有啊，就刚好。
哎。
一个人转，一个人转，对吧？
那个小红书啊，没有电子版的咩？馋过时了。50岁，你说这可以干嘛？50岁的血是一样的。啊，50岁的血要我们。
到最后我算不出来，我就想50岁。
那个血的活性就低了。说
早八天敌。
早八天敌啊！
写了这个 PEY 2_.
哇！
头像是一个猫，早八
谁又早八天敌？天敌姐，你懂这个天敌姐是谁吗？
他不是有。
啊，新色衣这个。
你有点到那里
他在跟早八天敌讲话。
你在跟早八天敌讲。
你竟敢不用敬语，尊敬的天敌。
早八天敌。 找啊找啊，找。
哇，太巴适了，那名字！以后改那种 game 的名字，我改成找吧。
Okay, so welcome back. So if you feel sleepy, yeah, you can slap yourself. I can help you too if you want. You want? Right? Okay, so in fact we still have another algorithm here. It's called support vector machine. But it's also into a very complicated. I'm not sure whether you want to continue this support vector machine or not. Okay, so I just explained to you the general ideas of some of the support vector machines. You have seen that just now the decision tree, we build a tree, right? We build a tree, and then we ask a question. If you have this equation, you have these features, fulfill, go to that direction. Fulfill, go to this direction, and so on and so forth. And then we have k nearest neighbor. It's a distance-based classifier. So we want to find out which point are actually closer to the unseen sample. Then we find the total frequency. Support vector machine meanwhile is machine learning models that will find the best hyperplane to separate these two classes. Okay, I repeat again. So support vector machine is a machine learning that will find the best hyperplane to separate two set of data. So you may ask, okay, if let's say I have two different classes, I can draw this line, I can draw this line, I can draw this and this. There are so many probability. Yeah, there's so many possibility. You can draw anyways, as long as able to segregate the classes. But support vector machine will actually find out a plane that try to maximize the distance between these two support vector. It's called support vector. Okay, so this is maximum. I will try to draw a line to separate them. That's it. Okay, and then the distance between this and this is called hard margin. And then this is the hyperplane. It's the plane that used to segregate these two classes. So when I have this plane, in future, if I have an unseen samples here, a new sample, so the machine will assume that any plane, any point that belong to this plane, it belong to star class. If your point is above this hyperplane, then you belong to circle class. That's it. Okay, so you have a hyperplane. So the models will actually find out the best for you, the best way that to maximize the separations, and then use for predictions. Okay, so yeah, so how the machines know that these points below this plane and above this plane are a little bit max here. So in order to identify if this point is below this plane, then we need to use a vector. What is vector? Vector is a line that consists of magnitude and directions. Okay. Yeah, you learned, but I believe that you already forgot everything here. So vector is where you have some magnitude, and this is the magnitude and the directions. Okay. So how to know that this point, the distance here is lesser than this plane or above this plane? So first we have to obtain the vector of these unseen samples, and then we will perform. We will actually draw a so-called a normal plane first. Okay, we draw a normal plane first from the origin to the hyperplane. Okay, and then we obtain the distance. The distance between the origin to the hyperplane, let's say, is equal to C. Try your best lah. Use a very simple term already. You have this hyperplane. This is the machine learning model. This is the machine learning model. So the distance between the origin to the hyperplane, I will give it as C, a distance. So now we have this unseen sample. This is a new sample. So we want to predict whether this new sample below or above this. So how to predict? Using your eyes, you definitely know that it's below than this plane. But machine is machine ma. Machine cannot see ma. Machine have to base on the calculations. So we have to project these vectors onto this normal plane using orthogonal projection. So we have to put this line into this line. Assume that this line will put onto this line. Okay, and then you have to know that, assuming that you have some distance here, we call this as a magnitude V. This magnitude, if you project here, the actual distance will not be the magnitude of the V anymore. It will become shorter. Correct? Now longer. If you project here, it becomes shorter. So how to measure, how to find the distance when we project this line onto this? So we have to obtain some delta, some degree. So how to obtain the distance here is equal to V1, your vector, cos the theta. Okay, you cos the theta, you will obtain the distance. Okay, so let's say the distance here I will denote as magnitude of W. Okay, I repeat again. You put a line from here to the hyperplane, so that denote as C is a distance. So assume that we have a new sample here with the distance of value 10, let's say. Okay, we want to project this 10 here onto this normal plane. Okay, you will have this distance of 10 cm. If you project here to here, the distance becomes shorter. So how to obtain this distance? You have to use this equation, V1 cos theta, you will get some value. Let's say magnitude W is a value, is a distance. Okay, by having this distance, then we can make conclusion. If your magnitude of W, which is the distance, is less than the C, so let's say the distance here, I give another value called D, is equal minus D, then this point belong to negative class. So this is negative, this is positive. Okay, if your magnitude of W is more than the C plus D, then it belongs to positive 1 class. This is how the machine classifies a new sample to either negative or either positive. If you can understand, you understand. If you cannot understand, forget about this. Okay. Yeah. So forget about this equation lah. As I mentioned, if you want to study master further study, then you have to understand this. Otherwise, it's apply. So, okay. So I'm going to skip to the last one. It's called naive bias. Yeah. So why naive bias? Okay. So recall back. This support vector machine is where we create the plane. Any point below this plane, okay, this is this class. Any point that above this plane, okay, you belong this class. Decision tree is when we build a tree. We assume the tree is an if-else statement. If this is true, go to this. If this is false, go to this. K nearest neighbor is the distance base. Yeah, we measure the distance. Okay, and then we linear regression for continuous value. The last one we have naive bias. Naive bias is based on the probability. Based on the probability. It's all about equation lah. So for naive bias, you have to remember this equation. Okay, boom. So this one is what you have to find out. You have to find out the probability. So this value, this, and this, you can obtain from the data set. Don't worry, you will obtain from the data set. This one is known as posteriori probability. This is so-called the hypothesis probability. This is so-called the evidence probability. And this is I think this is so-called, I cannot remember it. I cannot remember. So it's hypothesis. I cannot remember the terms for this one. You go to Google and then you check. I go to Google, I check for you. You just type bias. Okay, you click image. Okay, yeah, you have this term. Yeah, it's likelihood. Okay, yeah, it's likelihood. It's like okay. You don't really need to memorize it, but you need to know how to apply, how to substitute the value. Okay, because most of the time, if let's say inside the exam, the equation will be provided. You don't need to substitute the value inside. Okay, now let's see how do we apply to obtain the probability. All right, so what is hypothesis? First thing first, yeah, identify what is hypothesis. Hypothesis is referred to the class. For example, is it belong to yes, belong to no, spam, not a spam, and so on and so forth. H is the hypothesis. It's the refer to the class. D here is refer to your data, your sample, your feature. Okay, so this one you will obtain from the data set. So this evidence probability normally is a constant. You don't really need to find out. You just need to find out these two terms. Okay, straight away look at the example. Assume that you have this data set. Yeah, you have this data set. 4 features. First feature is the outlook, temperature. Second feature is dirt, and the fourth features. And this is the label, it's called class. So it denotes that a person, whether will play tennis or not to play tennis, it depending on these 4 factors. If let's say it is a sunny day, hot temperatures, high humidity, and windy days, okay, I'm not going to play tennis. No. Okay, if let's say overcast, hot, high, it's not a windy day, yes, I will play tennis. This is the data set I collect. Yeah, it's a data set, so it's a samples. So now I would like to predict. I'm going to use this dice to predict. Given that these new samples, rain, hot, high, and false, can you predict whether this, given these 4 samples here, will I play tennis or not? Okay, you want to predict. Given these 4 conditions or features, will I play tennis or not? Okay, it means that you have to find out what is the probability that I will play tennis. Yes, I will play tennis given these 4 situations: rain, hot, high, and false. I have to find another probability that I will not play the tennis given these 4 conditions. Okay, if this is higher, then I can make conclusion. Oh, I will play tennis because based on the probability. It depends on the probability. If let's say you obtain 0.5, okay, so I can play or not to play. If you obtain this is 0.9, this is 0.1, then I can make a conclusion that okay, under this condition, I will play the tennis. It depends on the probability. You have to find out these 2 probability. Okay, so how to find this value here? This value, it means that okay, you have to find out. So this is P H D. This is P H D. You have to find out is equal to P D H multiply P H. So it means that you have to find out what is the probability that under rain conditions I will still play tennis. Okay, rain conditions I will still play tennis. Multiply. What is the probability that under the hot conditions I will play tennis? Okay, multiply. What is the probability that under high humidity I will play tennis? Okay, and last one, last conditions, false, I will play tennis. And then lastly, pH, which is, what is our hypothesis? Play. You have to find out this value. Same go to this one. What is the probability that under the rain conditions you will not play tennis? Multiply, and last one, not play. So where to get this value? You find out, okay, from here, under rain conditions. Under rain conditions, how many values, yeah, how many occurrences that it belong to yes? 1, 2, 3, 3 lor, 3, and then 3 out of how many? Then you have to calculate 3 out of 9. Substitute under hot condition. Yeah, under hot condition. How many hot? 1, 2, 3, 4. Yeah, how many yes? 1. Only how many yes? 1 and 2. 2 over 5. Then you substitute. So basically, I already tabulated the table for you. So you obtain the probability from this data set, and then you substitute into these equations. Oh, sorry, so this is 9, not 5. It's under yes, under yes. Then you substitute the value. So from here you compare the value. So given these conditions, you are going to play tennis is only 0.01, but you look at this, under the 4 conditions, you are not going to play the tennis is 0.018. It's much higher than this. Then we can make conclusions. Given these 4 conclusions, I am not going to play the tennis because the probability is higher than I will play the tennis. Okay, so summary, you need to find out this value depending on how many classes. If you have 2 classes, you will have 2 probability, then you compare. If you have 3 different classes, you have to find out 3 probability, compare which one is highest. Then where to get this one? You have to obtain from the data set, from here. You calculate the frequency. Sunny days, okay, how many no? 1, 2, okay, 3, 4, 5, okay. No, then you substitute, okay, you put all this value. Then you substitute into this equation, that's it. Okay, so in fact, you had already learned all this during your secondary school as well. It's called conditional probability. You have learned probability, you learn about conditional probability. Yeah? Ziken. Is it? Yes? Have you learned this in the secondary school? Yes, yeah. Same. Just now, we're going to apply that into the applications used for predictions. Okay, yeah. So you probably have to take some time to redigest everything here. Yeah, I will just cover the most fundamental. Yeah, I may not yet go through the XGBoost, not yet go to the deep learning. Yeah, but that is the most fundamentals. Yeah. Go back. So tutorial, we have some few questions as well, right? We have a few questions. Yeah, try that question. What's the time now? For the stage, we just have some time. Okay, so once we build these models, everything's here, we have to measure the performance. Okay, so how to measure the performance for regressions, the linear regressions? You can use the square errors, some square errors, mean absolute errors, and others. For classifications methods, we can use a confusion metric. Is the most common measurements. It's the most common technique to measure the accuracy, the performance of the models. Okay, how to build a confusion matrix? Okay, it's not that difficult as you think. Yeah, it's just a table form. Okay, so assume that you would like to predict whether these patients infected with some disease. Let's say you have a total 165 samples. Okay, out of 165 samples, you have 105 that infected the disease, and you have 60 not infected by the disease. Okay, so out of 105 here, your models predict. Okay, your model predict that 100 is yes, 5 is no. Means that there's some wrong here, there's some misclassifications here. So out of 60 no samples, means it's not infected by the so-called virus, your model identified, oh, there are 10 infected with the virus, which is wrong classifications, and 50 that belong to no. This is, then we build a confusion matrix. Okay, so we build a confusion matrix. So where you have a predicted no and predicted yes. Then we have actual samples. So let's say no and yes. Okay, so you just based on this information and put the value inside. So out of 100 yes, you managed to predict. So out of 100 yes, okay, you predict this is okay. So out of 105 here, 5 no, you predict 5 is no, you predict 5 is no. Okay, and then out of a no, actual no here, 10 you predict yes, and then 50 you predict as no. That's it. That is how we build a confusion matrix. Okay, you have to be very clear first. There are how many total samples? Out of 165 samples, how many belong to yes and how many belong to no? And among these 105 that belong to yes, how is your performance of your model prediction? Is it 100 predicted yes, 5 predicted no? Then we just put this value into this table. Okay. Okay, so in these tables, we can further obtain information called true negative, false positive, and false negative, and true negative. So if your models manage to predict correctly, then we will call this as true positive. Okay, your predict no, but actually is no. Yes, it's true also. You predict correctly, but since no is also called you predict the disease, right? Disease is your objective. So I will give a label called positive. Other than this, that you want to predict other things that is not your objective, I will give a label called negative. Yeah, so in this case, it's true negative. So if you actually is yes, but you predict no, so this is wrong, so it's a false positive. So this is a false negative. Okay, sorry. So this is false negative. This is false positive. Yeah. Okay, so what is the purpose that we put this true negative false positive? Is we want to obtain the parameters called accuracy, precision, and recall. So by having this value here, this is the equations. Yeah, it's a true positive plus true negative. We just substitute this value into these equations, then we will get this value. So that is representing the accuracy, precision, and recall. So in your models later on, you cannot just obtain the accuracy. You have to make sure that these three parameters achieve 85% or 80%. Then it's only considered a good model, right? If your models achieve only like 70%, 65%, then probably something wrong with your model. So you have to fine tune it. Okay, so that is the metrics, the parameters that measure how good is your performance, if your machine learning performance. Okay, so and then we have another technique. It's called ROC curve, right? So it's mainly used for binary classification performance and measure the binary classification. This ROC is actually a graph that plotting using a true positive rate against a false positive rate. All right. So if you obtain this graph, if you obtain this kind of graph, where it will give you a very big area under the curve, that means that your models is good enough. It's good. If your models is give you this kind of graph, a very small area under the curve, that means that your classifier is having a bad performance. That's it. Yeah. And the last one is the cross validation, where we have a lot of samples. Assume that we have 1,000 samples. We can actually split into 10 samples here. 10 samples. So each sample here, you have 100 data set. So 100 times 10, you have total 1,000. So within the 100 samples itself, you build the models. You train the models, and then you do the testing. You repeat for 10 times. Then you check the accuracy, precision, and recall. Is it consistent or not? If consistent, then your model is good. If not consistent, then something wrong with your model. That's another way also, cross validation. Okay, yeah, that's it for today's lecture. I'm not sure how much that you absorb. You can understand, you cannot. Janice cannot. Alright, so see you next week. I would say this machine learning will be the most difficult chapters among these 14 chapters. So congratulations, we already gone through this chapter. So next week onwards, a little bit simple one.
一起看那个什么 graph 啊，那个这个，他是讲什么越远越不准啊？他讲什么越近越不准，越远越不准。
这个他是讲下面 area 比较多的话，
下面哪？
他讲他画一个 graph，然后下面的话你 area 比较多，他就会，他就 model 就比较 good。
哪个现在这个叫下面还是这个叫下面？
那个科法，
很多个课法。
那就，如果他这样 general 讲这个科法，好像这个图哦，
你在哪里？
那个画画
下面越多代表越准。
我说，
我刚刚问你上面那个是啥？
啊？这个啊。
不能再讲一个哦，矮的那个是矮的，高的那个。
Cross validation 是我有1000个 data， 我把它分成10个 box， 一个 box 里面可能100个 data， 对不对？我把这100个 data 我去做 testing 去 train， 然后出来的结果我把它的 accuracy 把它带入一个 accuracy 那个公式啊，懂啊？它不是前面写一个公式了咩？把它每一个的东西都放进去 accuracy， 然后后面就是代表这有10个 accuracy 的那个 data 嘛，对不对？这个嘛，我们去 compare accuracy consistent 还是 stable 没有？如果一个很高，一个很低，代表着你的 cross validation 是差的，是不好的，就是你的东西是不好的 cross validation。表达点了，好了，第一就好了，我之前在没有，我跟你讲，现在只是你在家里面什么，那个之前这样子嘛，就是我觉得蛮吵的。我这个是你考虑方面那个你打的那个圆圈，
我这个开始我一直在看这双鱼而已。你们在讲什么？
我家里的每个人。
你们在讲什么？他讲到我会讲，因为我讲也是先是。啊，
也要走，我也要走，我去吃饭。你应该要走。
他已经有点久哦，感觉。
好了，我去跑路了。因为他讲找不到吧？都来呀，因为他讲还去那个马斯加米，这个汤吧，有个水哦那个吧，就一汤吧。等。